Our next speaker is Victor Tenorio, initiating lunar mining operations for sustainable human presence.
Oh, they're gonna use it.
Oh, you guys.
Okay.
That okay,
And also this, if you would.
perfect. Okay. Okay. Good afternoon, everybody. Very happy to be here. And this time I just came with a student. First, I introduce myself, Victor Tenorio, Professor of Practice at the Mining and Geological Engineering Department here at the university. And I teach some of the core courses of the career, but also I have two passions. One is information technology applied into mine productivity that I use in part of my doctoral research and continue promoting it in the career. And the other one is space mining or moon mining in particular. I am teaching a course for graduates called Introduction to Moon Mining, another called digital mining that for all the technologies associated with it. One of the things that we are presenting now is we are keeping an eye on the mining side of the work. We are talking about in situ resource utilization, which is basically looking for materials, water, minerals, metals, and other non-metals and industrialize them. So that is the bootstrapping part. But we're now focusing on the mining itself. And we start with kind of understanding how does the IC regolith, or regolith in general, but IC regolith, where we're looking first for water, presence of water. We have had several presentations in where we are kind of being aware of knowing that there are areas of high probability of presence of water, and how this has been kind of identified in a sort of a stratigraphy, a stratigraphic column that we have here. And one thing is that at the beginning, we know that we start with powdery material, typically dry or barren, and then we have the next level is that we're going to have ejecta. We're going to have drops of ice or water, or and also particles of several metals, mainly nickel and iron from some of the meteorites that are falling into the craters. This may be happening in all the moon, but in particular, we're focusing on the permanent shadow regions. And the material is going to become more and more harder. Pieces will be bigger, will be more difficult to mine or excavate. NASA is providing us for some of the competitions that we have participated, the two versions of Break the Ice Lunar Challenge, and recently Rascal, that is a kind of a different type of competition, but they are more related to logistics for the moon base in the future. But these are kind of three simplified levels of regolith with different percentages of water. We are using this image for showing the underground mining 101, and there's a slight difference between the surface and underground mining on the earth. And these are some of the activities that we do. Started with drilling, then we load these drill holes with explosives, then blasting, ventilation, then mucking up or loading, hauling, and dumping the material that we mine, then scaling for losing or for taking out the loose rocks, then bolting for reinforcement, and then surveying. So this is done repeatedly for every mining cycle, typically every day or every shift during the life of a mine. And these things are going to change on the moon, starting with the length of day and night, the low gravity, and so on. So we have put our eye for this presentation in a family of equipment that has been designed already for the moon, for doing the first mine operations, the pioneering operations in where we're going to collect regolith and other materials. So this equipment is trying to mimic the cycle, the work cycle, but with the advantages of the new technologies. I allow Ethan to continue with the presentation of this equipment, and then I'll be highlighting some of these things. Please.
Hello, all, and thank you for introducing me, Tito. My name is Ethan, and I'm a junior geotechnical engineering with the College of Mining Engineering. To start off, I would like to point out our surveyor equipment, and that would be this one on the very left side. It would be the first piece of machinery on the moon, specifically using a myriad of different sensors, hyperspectral veneers, all of them together to pick out the ideal operations of mining. And with this range of equipment, it can be utilized for underground and surface mining. So leading on next to our excavator, regolith is, I was given the analogy, it's like a soft ice cream, to where it has a certain amount of kickback to it, to where this equipment was designed to drill many different holes in and come back with the articulated arm of the saw blade just to tear it up, enough for our collector to come in and get it into a load and bring it to an ideal dropping place, and or have our dozer come in and scoop it up and load it into our haulers for better ease of transportation. While this is all happening, we have a battery swapper essentially as our gas tank, keeping all of our equipment fueled and operational for the time being. Yes, the hauler there. Yeah. Okay, next we have our microfractors. So on the moon, typical hydraulics don't work incredibly well. And this has been a concept plan of microwaves breaking rock, essentially. And ideally, it would be used with solar power. But overall, this is our leading concept of how we would process rock into smaller material, especially with the lower levels of regolith.
Okay, so with the learning that we're having on these types of technologies and how we're going to start mining on the moon, we are reformulating our mining cycle. So it's going to be slightly different. First, the length of days and nights, the shifts will be longer, and we'll have to decide whether to just work during the daylight when we have solar power, or also during the night using kilopower or some other technologies for having electricity in the dark times on the moon. But the reformulation includes kind of the same cycle. I will start, as Ethan has said, with the surveying, releasing, deploying this equipment to advance and learn more about the terrain that we're working, along with more knowledge of the location of these deposits, the abundance of these deposits. Then do the excavation, then have some support that we're considering that underneath, it will be working with some of the mines on the earth with some sort of jacks of some sort. Perhaps not exactly like that, but that will be temporary support. Then collection, dosing, hauling, and then the battery swapping, while we also have to think about equipment replacement or have mechanics. Some things can be done without the intervention of humans, but others need to be done with human presence. And then all this centralizing a kind of supervisory system that we will refer at the end of this presentation, and all encompassed in what is going to be a wireless mesh. We need a wireless mesh that has to be developed, and LPS, which is the Lunar Positioning System, the equivalent of GPS on the Earth. I'll leave you this here.
So an ideal size of these machines are not going to be Earth-sized like our haul trucks we have. I was given the description that they're about the size of the desks you're sitting at, and they have a capacity to hold about 90 kilograms of material. So therefore, the design of the actual open pit mine is a concept of what we're seeing here would be much shorter and less of a slope than what you'd imagine if you've ever been to an open pit mine. This is an example of the underground operation, and as these equipment are all working together, I would specifically like to point out the excavator. Like I mentioned before, it's pretty much just enough to drill through and chop up the rock so the collectors can come in and grab it. Regolith just behaves a little bit differently than traditional rock on Earth, but we still have areas to proof of concept this. And as a proof of concept thing, we have our San Javier laboratory just south of Tucson. Luckily, the university owns it, and
Yes, go ahead.
it's a great area for just testing anything and improving. Ideally, we would like to stress test all of these machines on Earth before we could send them to the moon, and just hit them with as many different variables as possible to potentially not have losses. Here we have a couple different slope gradings at our San Javier laboratory, and this would be to optimize the different areas of specifically open pit mining. And our haul truck in the back there, that's going to be about 3 times the size of our other ones. But Tito, would you like to describe the slope chart?
Yes, here we have a kind of the first part of the proving grounds in where we can have, as it was referred also by the LARP team in the previous presentation, areas in where we can plant regolith or IC regolith. So we can have different areas, different angles of repose, and different material content, granulometry, and more or less presence of water that we can use for the same type of testing. So while the LARP team is doing the experiment extracting the water, we're helping them mining this. The equipment that we see there is called a scoop tram. It's 3.5 cubic yards. This is just for capacity, but most of the work that is done underground is done by that equipment. 2 or 3 of the equipment pieces that we have seen from the family of swarm robotic swarm technologies are going to do the same work, but in the moon conditions, which will be very challenging. But here also we have a chart of the actual behavior of the material on the moon, which is for ditches or berms or different shapes that we may need on the moon. And here's our surveyor equipment at large. And these are some of the renderings. I would like Ethan to continue with the next ones there.
You can go on to the next.
Yes.
We have an example of an open pit just starting with our excavator arm. And one other thing I'd like to point out is that articulated arm is not going to be hydraulic based on the reasons I mentioned before, but all mechanically based with wires, levers, and pulleys. The loader and dozer would come in just enough to load our next scooper image. This is just another transport, quick, similar to our loader. But finally, this all goes into a hauler truck and placed into a pit material. Next. Yes, this is our hauler, and this would just be for easier use of transportation to our final dropping grounds. One other thing is the wheels would be ideal for earthbound at the moment and tracks for Earth, but these very much could easily change in the future. I'd like to also point out that this is a nice operation of them all working together with the battery operator just on standby, waiting to fuel up.
I would like to add here that this is our own crown jewel. This is the decline that we have created at San Javier. Some of the pictures also from the previous team were done inside this decline. The old mine, the legacy mine, has sections of 5 or 6 to 6 times 6 opening section. This one is 15 times 15. It's very recent, and there's a lot of investment in equipment, technology, and dedication. It's highly instrumentalized. It has its own ventilation duct and several sensors, even for testing the micro displacements of the rock. We may need some of this on the moon as well. So we want to do wireless mesh and Wi-Fi and many other things in this area, and bring the equipment if we agree with the manufacturers to have testing equipment for doing endurance tests and durability and more. For the time being, this equipment is presented here with the earthbound or the earth type of tires that might be used on terrain. Otherwise, we can have the lunar versions of that. And the final part is that we will have here, this is part of the underground decline, and also the surface part for piling the material of different types. Last thing, the top of the cherry, is that we would like to have our centralized analysis of this. I think it's hot candidate for the MMOC that we have seen in the first presentations for for having the analysis of what we are doing. This is only the artistic view of what we'll be looking on the moon. Those tanks are of oxygen, hydrogen, water, and more. And with that, the last thing that we'll do is the benefits of having the testing at San Javier is our own, is from the university. We can welcome technologies and brands for testing things. And this will be conveyed immediately to the moon for the benefit of our participation on the mining process.
Good. Thank you all. Questions, please.
Yes.
Have you identified what material will be extracted from the moon?
Some of them. The most abundant is the basalt is the first one, which is the darker material on what we see on the moon from a distance. And basalt, there's a company, and I can mention this. It's called Pisces in Hawaii, and they're working with basalt coming from the volcanoes. They're giving shape to slabs, bricks, slates of different sizes. So eventually we will start doing part of our manufacturing process will be doing some sort of crucibles for solar power at the beginning or so to melt this material and give shapes to pipes, plates, doorknobs, rods of different type, elbows or things that we might need on the moon. That's the first one. The second is silica or silicon abundant material is the clear part of the moon. And that will be used mainly for the solar panels as a prime material. That will be the start. And then the abundance of nickel and iron from the ejecta of the meteorite that came from some forgotten planet that has been turned into smithereens in between Mars and Jupiter, perhaps. So we'll start collecting those and producing things that are made by these metals for the start.
Thank you.
All right, thank you.
Thank you.